Welcome to Uiua for Complete Beginners number 8. So we're looking at a Fibonacci sequence and a variant today. The problem's inspired, well, it comes from Rosalind.info. If you're not familiar with it and you're looking for some programming challenges, then take a look at that site. It's all based on bioinformatics and it aims to educate you in bioinformatics as you go. So it's pretty cool, and I'm going to be working through some more of the problems. So I developed an approach for Fibonacci numbers myself, but many people have done that. Once I got the Rosalind problem done, I solicited help on improving my code on the Uiua Discord, and the following users provided assistance. So we had Maya, Flopstar, and Edhebe. The assistance was all based around getting the stack ready for the real work. So that's a big focus of this video. Just to note, there's a big new release of Uiua today. It's 0.3.0, and it removes some existing functions and goes for a bit of an overhaul on how multi-dimensional arrays are handled. I don't really know the details. I'll be eagerly reading the new documentation soon, but some functions don't exist anymore. So if, combinate, and distribute, and I mention those because my earlier videos cover those functions or modifiers, and so just Uiua is very much a developing language. It's just the way it goes. It's exciting. Okay, so let's just see what we're dealing with today. Everyone knows Fibonacci sequence, so an example problem could, like, here's f sub 1 is 1, f sub 2 is 1, so the first two elements are 1 and 1. And then to calculate f sub n, then you just add together the previous two terms. That's Fibonacci. So if you were after the 10th Fibonacci number, that would be an example that we could try to find using code, or to write a function to get the nth Fibonacci number, or a list of the first n Fibonacci numbers. Okay, a modified Fibonacci would be to multiply the second last term by 3 and not change the previous term. This is based on the Rosalind problem, and the 3 is just an example. So more generally, if you're provided, let's say, a number capital N and a number k, then you have to find the nth Fibonacci number where you've got this k there. So it's not Fibonacci anymore, but it's a variant of Fibonacci. So an example would be if n is 5, so we're finding the fifth number, and the k value is 3, the answer is 19. So we start with 1 and 1, just like the normal fib numbers. Now the 4 comes from 3 times 1 plus 1, gives you 4. And then the 7 is 3 times 1 plus 4, gives you 7. And then 3 times 4 plus 7 gives you 19. So that's why the answer is 19. And going from normal Fibonacci to this modified Fibonacci is quite a challenge in Uiua, because you need to do this multiplication, but it's a value that's like passed into your function, right? So if I'm going to write a function that takes n and k, that means n and k are on the stack. Well, the actual calculation is a little bit removed from where they are on the stack. So the big focus of this video is stack manipulation. All right, so let's get into it. So to start with Fibonacci, I'm not going to go through this painstakingly slowly, but let's say we start with 1, 1, and then what can we do? Well, the approach I'd like to take is to take 2 of those, so that doesn't change, but I'm going to take 2 of a copy. All right, and then I'm going to add those 2 together. So I've got the 1, 1, obviously, and now I'm going to add those together. So reduce, add, so there's 2, and so 2 is my new value, and I'm going to now join that onto, right, and so I've now got 2, 1, 1, right? So if I reverse it, then we get 1, 1, 2, but I won't reverse it yet. Now, to calculate the next one, well, it's the same, right? I take the the first two, so I've got 2 and 1, and I add them. Oops, add them, and I get 3, and then I join them, and I now got 1, 1, 2, 3, but in reverse. And so if I do this again, I get 3 and 2, get the top 2 from the list, and add them. Naturally, that's 5, and join, right, and so on. So I'm repeating the same code to get more and more steps. So that means I can use repeat, right? So I can say repeat, and I'm going to join the sum reduction of take 2 of a copy, and repeat. I have to put a number here, so let's say I'm going to repeat 10 times, and there we go. All right, so I've got the first 10 Fibonacci numbers, or have I? All right, I've actually got the first 12 because I started with 2, and then I repeated the step 10 times where we add another one. So now we've got 12 of them. Okay, so what can we do about this this 10 business? Oh, now I don't actually want this this take 2 out. I think it's actually a fluke that this still works. There we go. That was just a mistake to leave that in. All right, so I've got the 1 and 1. So 1 and 1 goes on the stack. 10 goes on the stack, so I don't have to put it here. I mean, it obviously reads better there, but I haven't changed anything. And I suppose I'll take this and there we go. Make it a one-liner. And now if I wanted to make this a function, so I call it Fibonacci numbers, fibs equals that. Okay, so that doesn't take any parameters. I can just call fibs and I get that naturally. But if I want the 10 to be a parameter, then, so if I want to say fibs 10, fibs 20, then I need to actually flip this at that point. And there we go. There's 20 Fibonacci numbers. All right, I'll just do 10 just to see it's the same as what we had before. Okay, so that flip, I mean, if you've taken any interest in Uiua, then you must have got used to this flipping the stack by now. I'm getting more and more used to it as thinking of reversing a function arguments rather than flipping the stack, which I think, given that the stack exists primarily to support function arguments, then flipping function arguments rather than flipping the stack is a good way to think of it. But we start at the low level and we learn more abstraction as we go. Okay, so that's Fibonacci numbers, and that of course is in reverse. So I'm going to now reverse that, and there we go. All right, and so of course this, like, we can remove a lot of spaces, but that's up to you. Okay, so that's a good approach. I'm going to try a different approach. So that semicolon drops the first thing off the stack, so it makes it look in our output as though we never did anything. I'm going to do another approach to Fibonacci numbers where we use the stack for calculations instead of using an array. I don't like this as much, but it's just interesting to consider it for completeness. So maybe let's start with if I pop 1 and 1 on the stack, right? So I want to manipulate those, and I want to let's say I want to iterate 8 times. Well, rather than iterate yet, let's see what we can do. So how do I, the 1 and 1 are on the stack, how do I now get, like I want to get the sum of those two but without damaging them. So if I make 2 duplicates, right, and now I take the sum, right, so I've now got 1, 1, 2. I want to get rid of this one. Like, I don't want the stack to grow and grow. I'm just going to keep track of the last 2. So this is not going to be a function, not that it's a function yet anyway. This is not going to be a function that that produces a long list of Fibonacci numbers. This is going to be a function that finds the nth Fibonacci number. And so I just want to keep, I put two values on the stack originally, and I want to keep two values on the stack. Just like if you were doing this in some imperative language, you might call them like previous and current, and you just keep track of those two. All right, so that means I would now need to get rid of the first one. So that, there's different ways you can do this. I'm going to do a dip, dip, and then pop. All right, so dip, dip, meaning I go 2 levels deep into the stack and then do the pop. So that gets rid of the first one. And now I'm ready to, now I'm just ready to do those again, right? And I get my 1, 2, 3. And then if I do the dip, dip, pop again, then I've got rid of that one. Okay, and then, so obviously these 3 lines, so if I copy these 3 lines and paste, right, so now I've got 3 and 5. If I paste again, right, now I've got 5 and 8 and so on. So what I'm showing you here is if you know that you need to write some code that involves a repeat, but you're not really comfortable writing the whole repeat at once, you want to experiment, then all repeat does is just repeatedly execute code. So you can just copy and paste that code and see that it's doing what you want. And then when you're happy, put it into a repeat. So putting all of this into a repeat, let's say I want to get the 100th Fibonacci number. This will actually be, if I want the 100th, I'd better do this 98 times. And then even then, I'm not sure. So I'm going to stick with a smaller value. So the 12th Fibonacci number is 144. So let's see what happens if we do this 12 times. So I'm going to, I'm going to start my repeat now. So I'm going to repeat, I'll do my dip, dip, drop, my plus, comma, comma, and then I'm going to repeat it 12 times, and I'm going to start with 1 and 1 on the stack. What do I get? So I've got 1, 1, 2, 23, 3, 77. Okay, not too keen on that. Not really sure why I've got the 1 and the 1 still. Oh, that's because they're there and there. Okay, right. Okay, there we go. All right. Now I'm going to change let's just change that to a 5. Let's see what we get. 8 and 13. And the numbers are 1, 1, 2, 3, 5, 8, 13. So if I've got a 5 here, then I end up with the 7th Fibonacci number at the top of the stack. Now, in any case, I want only one value on the stack from this, so that means I need to dip and drop. Okay, so I just get the 13. And so if I wanted, let's say I want fib equals, right, and I want to calculate, say, the 7th Fibonacci number, which would be 13, then I need this to be a 5, right? So what can I do here? What I really want to do is like reach over the 2 1s, right? Because there's when I call this, there's a 7 on the stack. I want to reach over the 2 1s and grab it and pull it in. That's not trivial to do, and I'm not going to improvise that now. I'm going to kind of cover that later on. So anyway, I just wanted to explore this approach to Fibonacci numbers of using the stack. I don't like it. I prefer this because I think it's more idiomatic to say if you're going to iterate on something, iterate on an array, right? You're iterating on like one thing, the array is one thing, rather than 2 things on the stack. I don't know if that opinion is widely shared, but yeah, having experimented with both, I think this top bit is much nicer code. Okay, one thing that we can do, which is I'm gonna do this. It's a little bit of a diversion. Okay, so I'm going to say I've done fibs 10, and that gives me 12 things, right? So let's say I want to let's say I'm going to like subtract 2 from the thing. So if I subtract 2 from the argument before it goes in, then I pass in 10, and it subtracts 2 to get 8. The 8 ends up being the argument to repeat. So it repeats 8 times. We've got the 2 original ones. That gives me 10 altogether, right? And then I can say, if I want a function of, say, fib, and so, right, remember I want to say, if I want to say call fib 10, and I should get 55, right? So that means I'm going to call fibs, but then I'm going to take the last of fibs 10, right? So last is just the first of the reverse. Okay, and there you can see fibs 10 does produce 55. Fib 10 does produce 55. Okay, so what's the problem here? Well, fib 1 is going to produce an error, but it shouldn't, right? Fib 1 should be 1, fib 2 should be 1, and fib 2 worked. And that's because when we subtract 2, we got 0, and so I guess you can call repeat on with an argument of 0. But if I call fib 1, then I'm calling repeat on an argument with an argument of -1, and that doesn't work. So there could be like a try-catch kind of way to handle this. What I'm going to do is this, right? I'm going to make this like an implementation function, right? So fibs A, and my actual fibs function is going to have now a bit of a guard in it. So I'm going to use a switch statement. So if is not a thing anymore. So basically, if you provide an argument of, let's say, right, so let me just say, right, so the switch statement is you provide as many functions as you want to. So I'll just call them F, G, H, and so on. And then you provide a condition, and the condition has to evaluate to 0, say 0, 1, 2, and so on. Right? So if it evaluates to 0, then F will be executed. If it evaluates to 1, then G will be executed. And if it evaluates to 2, then H will be executed, and so on. If it evaluates to 47 and you don't have 47 things here, then you get an error. Okay, so my condition is to say, well, is the argument greater than 2? So if I call fibs 10, right, then I'm wanting to get an array like that back. So 10 is 10 greater than 2? Yes, it is. But I can't consume the 10, so I've got to work on a copy of it. So now that's either going to provide 0 or 1. So we're only going to have 2 functions, right? F or G. And so if it is greater than 2, then it means I can call fibs A, right? And so how do I call fibs A? Well, like that, fibs A, right? And if it's not greater than 2, so that means if it's like 1 or 2, look, if you provide a negative number to this, then you're going to get an error, and that's your own fault. So what I'm going to do is say, I worked out this cool way. I'm going to say keep that many ones, right? See how I've switched the order. So if the argument here was 1, then I'm going to keep 1, 1. And if the argument here was 2, I'm going to keep 2 ones. If the argument was 0, I'm going to keep 0 ones. So it actually works nicely. So I should be able to run this now. There we go. So fibs 10 works nicely. And fibs 3 works nicely. Fibs 2 works Okay, so that's actually using that's keeping 2 1s, and fibs 1, that works. That's keeping 1 1. And what about fibs 0? Gives me an empty list. So it's actually worked out quite nicely there. So there's a switch statement. You can't use if anymore, but this is like an if statement. Okay, so now, so that was just a little interesting diversion, and now we're going to do the Rosalind problem. Okay, so it's a variant of Fibonacci. Okay, so let's start with a bit of experimenting, and I'm going to just drop my 2 things off the stack here, so that, okay. So let's start with 1 and 1, and let's see what, like we've already calculated some fibs and stuff, but let's see what we can do. I'm going to say take 2, and then and take 2 of a, right? But now I need to multiply the first one by 3. So what I can do there is put this on the stack, 3 and 1, and then I can call multiply, and now I can add those. So basically that's F1 and that's F2. Okay, now that's to calculate F3. This is now 3 lots of F1, and that's F2, and now I'm going to add them together. That gives me 4, and then of course if I join that, then I've got 4 1 1. So we're building our list in reverse again. And now what do I need to do to get the next one? So I think I need to take the 2 of them, and then take the 4 and the 1. I need to put 3 1 on the stack, and then I need to do the times and that. So I'm going to condense this because I'll tell you what, I'll condense all of that because we're well used to that. And okay, and so do that again, right? And now we've got another one. Now I didn't get a 13 before, so it looks like I've in my rush I did something wrong. So multiply those, and then add the result, and then join it. Okay, and now if I reckon if I can take those 3 lines of code, okay, so something's going wrong. I think I need, right, okay, this is what's going wrong. In my mind, I'm developing the list towards the right. I know it's ridiculous because I can see it right here that I'm developing it towards the left, but when I, in my earlier development of this solution, I actually did do it towards the right, and it just feels more natural. But right now I'm developing it towards the left because that's what I did before. I'm going to actually, I'm going to start this again. I actually am going to develop it towards the right because why not? So that means I need to take the last 2, which in this case is no different, but of a copy, and then I need to put 3 1, right? And then I will do the times and the plus and the join. Okay, 4 1 1. All right, and now if I take the last 2, sorry, I need to join at the end, so a colon has to go in here. There we go, to reverse the arguments to join. Okay, so now I take the last two, so I get 1 and 4. I need to pop 3, 1 on the stack, right? And I do this bit, right, and I get 1, 1, 4, 7, right? So these 3 lines, oops. Right, these 3 lines are what needs to be like copied, right? And I am getting the correct values here because I've, calculated them before and they're values that I showed. Okay, so this needs to go in a repeat. All right, so I can repeat. Let me go join, swap arguments, take the sum of the product of 3, 1 and the last 2 items copied, right? And I need to repeat a certain number of times, and there we go, right? I'm getting good values here, right? If I do 50 times, I'm getting, there we go, lots and lots of values. Okay, right, so what's the problem with this? Well, a couple of problems. I mean, first of all, the 50 argument is here instead of like being passed in. Like I want to make this a function naturally. I'm just going to call this function f. Right, and this is just a little function template I do just to get the indenting right to begin with. Okay, so I want to create a function f, and if I call f53, then that needs to give me 19 because it's the 5th item in the sequence where 3 is the parameter. Okay, and naturally enough, if this is not much good because now if I this is just putting 3 and 5 on the stack and then calling the function because nothing here actually consumes an argument, but it's my starting point, right? Okay, so let's work first on maybe getting this 50. So this should be 5 now. Let's get this 5 in the correct position. Okay, and I'm going to can that. Okay, so what we can see now, I'm calling f53. So reading right to left, 3 goes on the stack, 5 goes on the stack, and then f gets called. So 3 and then 5, and now f gets called, which like nothing happens with f. It just calculates this value. Right? How can I make this so that 5 goes on the stack? Well, that's not hard. I just put a colon in there, and I think that should be right. Yes, so it's consumed the 5, right? The 3 is still here. Okay, and so now so what we've got, like 1, 1 is like our base, value, and then here's our repeat. But the 3 is used inside here, and this is the difficulty with this, and this is why it's a good thing that we get to learn about Uiua with, right? The 3 is used inside here, but it's like 3's on the stack here. How can I reach back and get that 3 and then pop it inside here? So trick question really, because what I'm going to do is put a 3, 1 here, right? So far, okay, that failed because I'm interfering with the stack with the 5 coming in. So I might actually do that and then change this back to a 5. Okay, so what's happening here? 3 and 5 go on the stack, 3, 1 goes on the stack, and then all of this gets calculated, right? But what I want is to be able to use this 3, 1 and not that 3, 1. Or I'm going to basically, look, I'd like to develop this more bit by bit, but I'm just going to cheat and show my answer. So I had a take -2 dot, which means that it would take the last two of this, or whatever this array is, because it grows. Now, comma is like an idiom for give me a copy of the last two things on the stack. So it's actually giving me a copy of the 3-1 and the 1-1. Now remember, the 1-1 grows to be the answer, but the 3-1 is actually just going to stay 3-1. 3-1 is what I need to help calculate this thing. And then everything else is actually good. Surprisingly, it works well. I'm still doing the multiplication. The two arrays, the 1-1 and the 3-1, they're in the opposite order now, but I'm still multiplying those two things, and then I'm getting the sum and I'm joining them to the end. So all is good, right? So if I just, okay, so there we go. So what I want to happen is, now if I change this to, let's say it goes up, like the parameter is 7, and I want to get the 13th item, all right, then, well, 13 items, right? So there's 13 items, and it's like, I'm not going to check the arithmetic, but the parameter is 7, okay? The 5 and 3 here have been completely ignored, but what I need to do is I need to turn, so I'm going to actually make this a function, just a new function to play around with. I'll call it G, and the G, I'm going to call G 5 and 3, and what I need to see on the stack, and I'll just change this back to what it was before, because, right, what I need to see on the stack, the top of the stack needs to be 5, that's the argument to repeat. Then we need the 1-1, that's a constant. And then we need the 3-1, which is generated from the 3, okay? So this is like just to do the initialization. So what can I do? Well, my first approach was not very nice. So my first approach is to subtract 2, right? So if I call 5, 3, then now I've subtracted 2 from the 5, so I've got 3, 3, right? And now what am I going to do? I'm going to do a dip, because now I need to act on this 3 and turn it into a 3, 1. So the dip, well, I'm going to join it to 1, right? But that gives me 1, 3, so I'm going to reverse instead. Okay, so there we go. Right, so I'm subtracting 2 from the top of the stack, and then dip means I'm now going to the second item on the stack, and I'm constructing the 3, 1 out of that. And now I need to also put in a 1, 1, right? So remember, there's a 1, 1. Okay, but now they're in, like, the 3's not in the right order. So looking over here and seeing like what we want to get, the 3's not in the correct place. I'm sorry about the confusion between the 3's, by the way. I'm going to change this to a 10 and then this to an 8. I think that, okay. So the 8 needs to go down, so that flip will work. All right, so there we go. So these 4 lines of code here takes the 10, 3 and sets up what we need here. So I can now copy that, paste it here, get rid of those. So I've got 4 lines of code that set up what I need, and then the repeat that does the job, and then I can call F53 and I get the 114719. Okay, so that's good, that's progress, but this code's not very nice. So that's when I asked for some help on like what's a more idiomatic way to set up these things, right? And I've actually got 3 improvements to show you. So we'll focus on the G function rather than the F function. because it is really just about setting things up, right? So so rather than so let's get rid of this. So the first improvement came from Mayer, and what we'll do is we'll put the -2, well, like as in we'll operate -2 on the top of the stack, and then we'll do a dip. And the little innovation, which I never ever thought about, was that I can put the 1 and 1 right here, and then do my join, and there we go. And that gives the values that I need, right? So this function is actually working, right? And so I guess what I can do is copy that, paste that, okay, and test my, right? And so there's my nice, result from F. Okay, so that's a nicer approach to setting up the parameters. It's going to get better, right? But the way that's working is like we've got we've got the function. So 5 is placed on the stack first, and then 3 and then 10, right? Okay, so the -2 acts on the top of the stack, so that's now 8, and then the dip acts on all of this, right? And what the function that dip is calling, right? I just never thought that you could put a constant value in a function like this, but it makes perfect sense now, because the output of a function is just to drop things on the stack, and it doesn't have to be just one value. So the first thing it does, because we read right to left, is to call the join flip on and 1. So that produces the 3, 1, but it also puts a 1, 1 on the stack. And that's exactly what I need. Okay, so there's a nice little, this is not the best solution for this problem, but there's a nice little takeaway there. Just a note to myself, when you're thinking of a function, and a function, by the way, doesn't have to be like when you're writing a function like this. It's like when you're calling, rows or each or dip or whatever, and you're providing a function in brackets, well, yeah, you can output more than one thing onto the stack. Okay, so that's one way to do it. The next one came from Flopster, who used fork, and this is a really nice thing. So if I start here again, then and I'll just comment this. Okay, so fork is you probably know from earlier videos or your own experience with Uiua, but a quick demonstration of fork off the top of my head. If I put a hello world, right? Actually, I only need one value on the stack for, right? So there's hello is on the stack, and if I call fork and I call length and I call reverse, then it produces 2 values, right? And so I'll just comment that as well. Okay, so so hello was on the stack. If I put a dot here, then we'll see the original. All right, and then fork, it reads that one value, but it produces 2 values, which is really nice. So it's produced the length and it's produced the reverse. Look at the order. The length is at the top of the stack. Now the stack grows downwards on the screen. The top of the stack is 5, and it produces the reverse. Now you're not limited to one function in, one function out. I could take a lead here and put a let's choose a so I could put a constant value in there, and these parentheses are not necessary, right? So if I say fork reverse and length, okay, then that's the other order that I had from before. There we go. Now brand new in Uiua is to allow you to provide not just two functions, but multiple. So I could have reverse and length and rotate 3. And there we go. It's produced 3 values in there, right? So this syntax of using the pipe inside brackets, so separating functions, I believe this is colloquially called a function pack. I'm not sure what the documentation calls it. And yeah, so fork is awesome, and fork can be used here. So just setting up. Oh, that was silly of me. Okay. All right. So what we can do to produce the stack that we want is I can say, well, at the top of the stack, I want to take 2 off, right? So I want to take 2 off the first thing. And then my second thing that I produce is just the constant 1, 1. And then finally, I'll produce, I want to produce the value, if we call it k, I want to produce it k and 1, right? Now, before I get there, we're going to produce 1 and k. Now, what's k? K is actually the second item on the stack. Remember, we're calling this with 10 and 3 on the stack already, right? So, so 3 and then 10. 10 is the top of the stack. So when fork, the first function is -2, so that's going to produce a, like that's, so not -2, -2. That's going to produce 8. And then the second function is 1, 1, 1. So that's going to produce that there. And now the third one, when this operates, it still sees this stack. Okay, each function sees a copy of the stack, and so what we want here is to get the second thing from the stack, and that is a gap ID. Okay, now this is nearly correct, right? So a gap ID. So what gap does is it gets rid of the first thing on the stack. Now, of course, I could probably, so that one didn't work, and I'm not going to even try to work out why. It's idiomatic to say, right, you can have as many gaps as you want to like just get rid of things from the stack, and then take the ID to say, yep, I'm going to have that one. So this is a thing in the documentation called planet notation. And if you're not familiar with it, then read about it. I read about it several times before, but never quite really got it because I didn't have a problem I was trying to solve that really needed it. So turns out I don't need much of it in this problem, but I did learn a lot about planet notation like while trying to solve this problem. Okay, so this is basically getting the second item off the stack. Now it's not destroying the stack because this is inside a fork, so it's seeing a copy of the stack. Okay, so now this, so now if I call G103, which I have, then we get this 1, 3, 1, 1, and 8, which is almost perfect, but I'm just going to reverse the, there we go. So 3, 1, 1, 1, and 8. All right, so this is a really nice approach. So I'm going to copy it and paste it here and get rid of that. Okay, so this is nicer than the previous one because we've got like one line here that sets up our like values and then one line to do the repeat. Now the line that sets up the values, we need 3 values in order to do this. And look at the fork, it's very explicitly producing 3 values, right? The current stack has 2 items on it. Each one of these functions gets to see those 2 items. And this one is going to, you know, take 2 off. This one doesn't affect them at all. And then this one is going to do the, you know, the 1, 3, and then the reverse. The important thing is that the function signature for this, the function signature for this is 1.1, meaning where I've got the 1 highlighted there, it's consuming 1 item from the stack, and here it's producing 1 item. And so that means the net thing here is to just produce 1 value. This one doesn't consume anything from the stack, and it just produces a value. So that produces 1 value, and this thing, it consumes 2 items from the stack. You can see there that it's like chops the first one and then consumes the second one, right? And yeah, so in total, the way fork works is the maximum number of items that any of these consume is 2. And so that means 2 items are now gone from the stack forever. And in their place is the output of these functions. Right? It's very nice. Like, I can't pretend it's simple. It is complicated. Stack-based programming is complicated when you're not used to it. But this is very elegant because it's like, as I said, it's basically saying we need 3 values on the stack. So I'm going to do a fork with 3 functions to produce the 3 values that I need. So very nice takeaway. And then finally, and if I call the function, then I get my. Now, I should point out, should have pointed out already. I'll just copy this one, comment this one. When I call my function f, I've actually got this 3.1 lying around because that was needed in the calculations, but it's not needed anymore. So what I should have done already is to dip into the stack and delete it. So there we go. So f is now a nicely well-behaved function. And I really like that. 1 line for initialization, 1 line for calculation, 1 line for cleanup. Very nice. Okay, finally, I'll just operate straight in here. Thanks to Ed Hebe on Discord. Now, of course, people create usernames, using whatever algorithm they like, but they don't necessarily think about pronunciation because it's all just a written form. So anyway, I apologize if I'm, pronouncing something in a really strange way. So this final improvement uses bracket. Right now, what bracket does is it applies 2 functions to 2 values. At the risk of just repeating the documents here, if I do plus and times, right, then if I have 5 and 6, then that doesn't work. Okay. Has something changed such that bracket doesn't work anymore? I mean, I was always a bit of a novice with it anyway. Just doing a quick check of the documentation. Sorry, this doesn't make for good video. So bracket still seems to exist. What have I done wrong? Few more seconds while I do a search. Okay, right, now I understand. Silly me. I'm sorry for this. It's a terrible thing to watch, but right. If I replace this with fork, right, then this is funny. Oh my goodness me, it was there. Okay. Okay, right. All right, okay, down here, fork plus and times gives us 5 plus 6 and 5 times 6 on the stack, right? If I want to use bracket, like I'm such a novice at this that I don't even know how to do it. So if I do plus and times, plus requires two values. So if I give it 4 and 5, that's going to give me 9. And if I give it, say, 10 and 12, that'll give me 120. So there we go. We've got our 9 and our 120 on the stack. All right. Now, what is that an improvement over? Well, let's say I had 12, 10, 5, and 4 on the stack, right? Then how could I get the same result without bracket? Well, first of all, of course, I can do a plus. So that gives me the 9. And then to do the 10 times 12, I need to do a dip times. And that gives me the 120. So the bracket is better than doing the plus and the dip times. I've done one function and then dip another function many times before. I should have used bracket. So here we're operating on, let's say, right. So if we're calling the function with the parameter is 3 and the repeat is 10, then we can do bracket and just find my code again. No, I've lost it. Okay, well, I'm on my own. So bracket. So I want to call a function on, 10. So I'm going to call -2. And then now I want to call a function on 3. And that is, I need to put 1, 1 on the stack. And I need to do what I did before, the reverse of 1 gap ID. Okay, and if I call okay, so that if I call the G function, no, I won't call the G function because I haven't been working on that. If I call the F function, then I get an error. Okay. All right. Well. Okay. That's because, right. That's because the gap is not needed here, right? Because the bracket is saying we're going to apply this function to the top of the stack and this function to whatever comes after. This one consumes one item from the stack because it only reads one item, and this one only reads one item because of this ID. Okay, and so this is going to work now, I promise. There we go. Okay, all right. So I learnt a lot in solving this problem and getting help in improving it. I hope that that's come across in the video. I'm sorry that some of it was a bit shambolic, but the path towards mastery is never smooth, and this video doesn't have to be super smooth either. All right, see you in the next one.